For centuries, trains have been a cornerstone of transport, moving goods and people across distances.
But railway networks are complex, and trains frequently need to navigate junctions, change lines, or access.
This immediately presents a critical challenge. How does a train, designed for rigid, straight movement,
This is where the engineering marvel of track switching comes into play. Without it, the extensive railway networks we rely on.
In this video, we'll explore the ingenious mechanisms that make track switching possible. Railway networks are marvels of engineering, designed to move goods and people efficiently across vast distances. A simple crossing, where two tracks meet, creates a fundamental conflict. If two trains arrive simultaneously. For simple crossings, trains must take turns, one waiting for the other to pass. But what if we could design a junction?
The answer is an ingenious piece of engineering known as a slip switch. This complex mechanism allows for both crossing and easing.
This allows trains to diverge onto different tracks or cross other lines without requiring multiple separate switches.
This allows trains to diverge on.
The elegance lies in its ability to physically shift the rail sections, known as point rails, allowing for the precise
As the point machine actuates, the connecting rods transfer motion to the point rails, changing the alignment of the track.
This precise movement creates a seamless passage, allowing a train to change routes safely and efficiently.
Thus, the slip switch ingenuity. We now turn our attention to the heart of railway versatility, the slip switch railway crossing. Its primary function is to facilitate the complex routing of trains, enabling efficient movement across.
Let's identify the key components. The primary load-bearing rails, which maintain the continuous path for the train, are known as the stock rails. Adjacent to the stock rails are the movable switch rails, which pivot to guide the train onto a diverging path.
Finally, facilitating smooth passage for trains navigating the intricate layout of the slip switch. To truly grasp its function, we will now simulate the basic movement of a train traversing this complex intersection.
As the train approaches, the switch rails precisely align, directing it from one track path to another with critical accuracy.
Observe how the train flawlessly navigates the intersecting lines, guided by the precise alignment, ensuring a...
With the train now safely on its new route, the slip switch mechanism resets, ready for its next command. Now, let's observe how the slip switch mechanism responds to a command, enabling a train to change its path. A control signal, highlighted by a vibrant green glow, travels along the wire, initiating the switching sequence by activating the point machine. The point machine's internal mechanisms, revealed through an X-ray view, show a piston precisely driving the throw rod. This force is transmitted, initiating the precise leverage movement of the switch rails. Observe the critical points of contact. The rails continue their controlled motion, establishing the new diverging path. The color coding clearly. With the rails now fully aligned for diverging path, the critical locking mechanism begins its precise engagement.
The locking mechanism now fully engages, securing the switch points and ensuring a stable, safe route.
With the diverging path now securely set and locked, a semi-transparent train model approaches.
The train model demonstrates the successful and seamless transition across the slip switch. As the train completes its passage, the slip switch mechanism prepares for its next task. As the train completes its passage, the slip switch mechanism prepares for its next task. We will now explore teams. The control system activates the solenoid valve, directing hydraulic fluid at 110 bar, resulting in
The slip switch is now engaged for straight passage.
From the precise animations of our studio, we now shift to the real world, observing the complex dance of rail and steel in action.
A modern freight train approaches a complex slip switch, where multiple tracks converge, requiring precise alignment for safe passage. Watch as the massive wheels seamlessly transition across the movable points, a testament to the engineering precision required for such. Once the entire train has safely traversed, the slip switch resets, ready for the next movement.
Beyond the seamless real-world operation, a deeper understanding of slip switches requires a look into their precise mechanics. A single slip crossing allows a train to move from either of the two main lines to an adjacent siding. In contrast, a double slip crossing, a more complex variant, enables movements between any of the four track directions.
The safety of these complex junctions relies heavily on interlocking systems. These systems prevent conflicting movements by...
Crucial to interlocking are the detection rods. These physical mechanisms conform the exact position of the switch points before...
This physical verification is paramount. Any misalignment, even fractional, prevents the rods from engaging fully. This positive confirmation then transmits an electrical signal to the interlocking control system. This digital handshake. The interlocking system operates on a fundamental if-then logic. A signal cannot clear to proceed unless...
The complex geometry of the slip switch mechanism demands precise control. The point machine ensures reliance.
Ultimately, the seamless ballet of modern rail travel, from freight to passenger, relies on these sophisticated interlocking...
Ultimately, the seamless ballet of modern rail travel, from freight to passenger, relies on these sophisticated... Welcome to an in-depth exploration of the slip switch mechanism, a critical component in railway design. In the complex world of railway operations, safety and efficiency hinge on precise control mechanisms.